All right, so trait number one of mathematically proficient students is the understanding of what a solution means. So this, at the heart of it, is rooted in a simple sign that we call the equal sign. So the equal sign means to be. So if I write x equals to 5, this means that x is 5. So if left equals right, this means that left is the same thing as the right side. So the following directions on the SAT really are telling you to do the same thing. So if you see find the zeros, find the x-intercepts, find the solutions, and find the roots, this means that we are effectively solving the equation. So I could have any type of graph that I want, literally. And if I am given instructions, I can actually find, the zeros, the x-intercepts, the solutions, and the roots. These all mean the same thing. So let's take a look at this on some example questions. So kind of to give you a guideline of the different levels of questions, one could actually do the concept of equals and solutions even without knowing any algebra. So you could be given random equations and you could test out each answer choice to see if the left side and the right side are equal just simply by plugging something in. You could, at the linear equation level, get x by itself by just performing reverse operations. So the opposite of multiplication is division. The opposite of addition is subtraction. The opposite of squaring something is square rooting something. And then at the quadratic algebra 2 level, we want to be looking at pulling out GCFs, factoring, setting each factor equal to 0, or using the quadratic formula if that does not work. So let's take a look at some sample SAT problems. So I like this first one because there's actually multiple ways that you could do this. So we could even start by just plugging in answer choices. So I could do 3 times the square root of 3 squared, and I could see, does this equal to 27? Now, one underrated property in math is that if I square a square root, the square root goes away. So I could actually do 3 times 3, and I could see, does that equal to 27? So I get that 9 does not equal to 27. So that would not be an answer choice, and obviously C would not be an answer choice. So just by simply plugging in the numbers, I was able to eliminate 2 answer choices with the first plugin. So let's actually go to 3 times 3 squared. So I could get to 3 times 9, and I could see, does that equal to 27? And it turns out that we get 27 equals to 27. So this obviously means that 3 is a solution. And let's kind of look at the negative version of 3 as well. So I could go to 3 times negative 3 squared, and I could see, does 3 and then a negative number squared is going to get me positive. So does 27, 3 times 9 equal to 27? It does. So I could see that both 3 and negative 3 work. So that's one way that I could do it. I could just plug it in and see. Let's actually outright solve it. So what a algebra 2 teacher would tell an algebra 2 student to do is to do 3n squared minus 27 equals to 0. And we would pull out a GCF of 3. And if you are in Algebra 2, you might recognize a factoring method that is called difference of two squares. So this would be a n times an n, and we would say that the square root of 9 is 3, and we put this in the format of a plus 3 and a minus 3. And it turns out that I get n equals to negative 3 or n equals to positive 3. But it turns out that I don't have to do, fancy factoring with algebra. So a way that I would do this if I were taking the SAT would just be to do 3n squared equals to 27. And I would say this is 3 times n squared. And I might ask myself, what is the opposite of times? And the opposite of this would be to divide. So I'm going to divide by 3. So I have n squared is equal to 9. And I ask myself, what is the opposite of squaring something? And the opposite of squaring something is square rooting something. And when I square root, I put a plus or minus in front of it. So I have plus or minus the square root of 9. So n is equal to plus or minus 3. So those are the 3 different ways that you could solve a problem like this. Now, here's a graphical example of the solutions, roots, zeros question. A lot of people might actually look at this question and kind of get confused about what it's asking, but zeros just simply means, x-intercepts. And we could look at this graph, and this is not even, a linear equation. It's a curvy, 4th degree function. And somebody, even somebody who hadn't taken Algebra 2 before could answer, this type of question. So I have, 3 x-intercepts, 1, 2, 3, in a matter of seconds. So just by being able to decipher what is being asked and kind of write it in a more familiar way, one could turn this question from something very confusing into something that is much easier.